Hi, for today's YouTube video, we're going to discuss about system design for hospital management system. So I want to explain how we can design a systems. Different designs I would like to explain for hospital management. You see here, the first thing is we are going to use a Kubernetes cluster. I hope you are aware of the Kubernetes cluster. Kubernetes cluster is a cluster of different nodes where we can deploy the services into pods. Okay, we are going to deploy per service pod. I mean, for every pod we'll deploy only one service. So one-to-one mapping for a pod with respect to service. So that way when every pod is having single service, so it would be easy to maintain the pods. The management of the pods would be very easy. You can actually spin up the instances, you can spin up the pod, you can create the pod, you can destroy the pod. It would be very easy for managing. If you deploy multiple services in a pod, it would become a little bit complex, so it is not recommended in the production. So better you deploy single service in a pod. Until and unless there is a dependency of two services, if there is a tightly coupled dependency between two services and you have to deploy them in a single pod, that time only you have to choose for deploying multiple services in single pod. Otherwise, go for deploying one service for one pod. So that way you can manage the Kubernetes cluster very easily. So here you can see the simple example is Kubernetes cluster is having 3 nodes, and each node is having two services. In a single node we may have multiple pods. So you consider here patient service. We deployed a patient service and billing service in one node, and appointment service, inventory service in another node, pharmacy service, staff service in another node. So we deployed like that. And we need a load balancer, you say, whenever the traffic is coming for your application. So Kubernetes cluster automatically scale up the number of services. So auto scaling option is there, auto healing option is there. You can configure multiple features using Kubernetes clusters. So that is why most of the companies are preferring to use Kubernetes cluster, because you can simply automate the deployment of the pods. You can configure the nodes. The cluster management very easy. You can deploy any application in a distributed manner. So it is a distributed cluster. You can simply deploy the application. So management of the nodes would be very easy if you are going to use a Kubernetes cluster. And you need to have a CI/CD pipeline, separate CI/CD pipeline, because you need to define the pipeline, how to build, how to compile, build, and checking the compliance against the code, and static code analyzers, running the static code analyzers against your code, or in verification of your images. These things should be taken care by the CI/CD pipeline. After that, the images would be deployed. They will be containerized and deployed into the Kubernetes cluster. Service registry is required. We can use the Eureka, because auto, as I told you, when we are going to deploy multiple services, so when the services are trying to communicate, it is very important. So based on its name, automatically the IP address of each service will be discovered, and the communication will be very useful. So service discovery is required. So you can use a Spring Cloud service discovery. And message broker, we can use a RabbitMQ or Kafka. If you want to build any notification system, alerting system, you can use that. It is very straightforward. Okay. And other thing is, so here look at another diagram. Whenever you're going to use microservices architecture, you need to choose a separate database for each service. So that is where the real microservices architecture will come into the picture. Because that way you can actually separate you can different databases, so you can maintenance would be very easy. Say for example, take a patient service, appointment service, both are having different databases. The database data schema also differ, right? So it is easy to maintain. So you can get the data for the respective database, and you can actually store the data in the respective database. So you can have a separate team also for maintaining the service and respective database. So Eureka server, as I told you, you can use the Eureka server as well. And you see here we are going to use RabbitMQ. So whenever in this diagram I want to tell you only one thing: whenever you are using a microservices architecture, you're going to use a separate database for each service. Getting that right? You need to do that way. Okay. So that's all I want to tell you, and let's see other databases as well. So whenever you are designing a system, these features you need to consider: the scalability, caching, replication, load balancer, CAP theorem. Whenever you are designing any system, you should keep in mind that you should build a scalable system. It should be feature ready, upgradable, flexible, right? You should be able to scale the application in on-premises servers, or should be able to scale the applications in cloud also. It should be horizontal scaling. You need to keep that in mind, horizontal scaling, and keep that in mind, vertical scaling also. Whenever for databases, sometimes you need to scale vertically based on the requirement. So for microservices and all, horizontal scaling would be fine. So caching is the mechanism. You have to catch some data, static content. You can catch the static content. You can use content delivery network, CDNs, where you can keep the static data, or you can also use open source Spring cache mechanism. So you can use third party caching mechanism. You can store the cache data. You don't need to hit the direct database. You can store the caching. So replication is required. So database replications are required. So whenever you are going to use some Oracle database for banking, financial services, you need to have a mirror database also. Sometimes you need to replicate the database, back up the database. Replication factor, you need to take the backup of the snapshots of the databases would be required, right? Load balancer, as I told you, load balancer, you can use any third party load balancers, or you can configure any load balancing software, or inbuilt if you are going to use microservices along the Spring Cloud. So you can configure the load balancer and routing mechanism inside the API gateway. You can do that. So CAP theorem is required. So whenever you are building distributed systems, you want to use a NoSQL databases. You cannot guarantee the ACID properties, right? So you see consistency, atomicity, and persistency. You can choose only two of them at a time. So the ultimate consistency or ultimate ACID properties, you can actually make your application to follow ACID properties ultimately at the application layer. CAP theorem is required, whenever you're dealing with application NoSQL databases, you need to keep in that mind. Okay. So I want to explain the difference between system design and software architecture. System design explains how different components are interrelated, how your complete system is having different components, how the communication is established between among those systems is called a system design. Architecture is, you have a application, so you need to explain what is the user interface, what is the business logic layer, what is the data access management and databases. You need to explain each and every layer, how user interface is interacting with the business layer, and how the business layer is interacting with the data access layer, databases using data access. So that is the software architecture. System design is a broader picture. So out of the box, you're going to explain multiple components or different components. Whenever you're designing system, you will have a databases, you will have a application server, you will have web servers, you will have asynchronous software system, Kafka, RabbitMQ. You may have different third-party servers. What kind of endpoint devices you are going to use? So you're going to have all these things, and also you need to keep in mind these features. See, whenever you're going to create a system design, you have to understand what are the modules, how you're going to provide security, the system is reliable, scalable, how maintain friendly it is, and you need to think in the performance perspective also. Okay, these things are very important whenever you are going to design a system. And you see modern system design modules in Java complete guide. You can see here the layered hexagonal architecture is simple. You will have a controller, service and repository, and repository will talk to the DB and you will get the data. It is simple layered architecture or hexagonal architecture. Most of the architectures are like this. This is called layered or hexagonal architecture. Request comes to the controller, and from the controller you will pass it to service, and from there you will talk to repository. The microservices architecture is you will have different services. As per the domain driven model, you will create multiple microservices. For each service you will have a separate database, and you are going to handle the integration set application, API gateway. You can aggregate the result set up API gateway and render the data. Reactive systems, nowadays people are using reactive system because they want to use asynchronous style of system design. So you can see the reactive databases, back pressure response. You will fire the request and forget there. Other side consumer will process it and they'll use the thing. And you can see serverless architecture is the one where you can write the your business logic into a function. You can simply deploy that in a server. You don't need to bother about the server architecture and where to deploy this particular piece of code. You just write a code or business logic into a function and you deploy that in the cloud. And cloud infrastructure will take care of the servers and initialization install of the particular piece of code into servers. Okay, so that is the thing. And CQR is a command query response segregation, I think, event sourcing mechanism. So here we'll have a event store, a producer consumer model, command query. Segregation is for writing. Whenever you are calling any APIs will write lot of data into database, and other APIs they'll read the data. So command query segregation, what they are doing here, we are actually separating out writing part from the reading part. The main intention is here, if you are getting millions of requests, writing requests, you should not club both reading and writing. You should separate out. There should be separate API for writing and there should be separate API for reading. This is called command query segregation and event sourcing mechanism. Okay, command query request segregation or something. R stands for request or response, I'm not sure. You can search for that. So you can see the intention is here you're going to separate out writing logic and reading logic. Both are different. You'll have a different services. You'll write the data into separate database, and there will be leader database, and once you write the data, the leader will automatically replicate or push all these writes into different slave modules as well. So you can get into the in-depth system design. So in a high level, that is the thing. So event-driven architecture is different. Here event-driven architecture is the communication will be established using producer-consumer model. Here event-driven will use asynchronous software messaging style, asynchronous messaging communication among the multiple services. Will actually produce the message into topic or into queue. Other side, the consumers, they consume the data. So that way you can establish the communication among the event-driven architecture. For building notification systems or alert systems, you can use event-driven architecture. Domain-driven design is, you can actually, as per the different modules, so you can actually design different services. For each domain, you have multiple modules, multiple functionalities, different functionalities. Each functionality can be convert that into a microservice, and you can design a separate service, atomic service. So that way you can utilize that service as an independent service. So that is called domain-driven model. For each domain, so we'll have different domains. You need to come up with the different functionalities, and different functionalities will have different microservices. Other architecture is AI ML integrated systems in Java. Nowadays artificial intelligence and machine learning models, they are playing vital role. You can integrate these AI ML models into your services using a Java. Okay, so that way you can do it. It would be so easy. So you can see majorly there are 4 types of architecture. Client server architecture, very old model. You have a client and server. It is a traditional model. Centralized server will be there. Your client will always talk to the centralized server, whether it is application server or WebLogic, they will be deployed there. And event-driven architecture is, as I told you, we're going to use asynchronous software asynchronous software. So messaging softwares like Kafka, RabbitMQ, any queue, AMQP software also you can use. Java is also providing, you can actually publish some events into a queue, and you can actually get that. It is an event-driven architecture. Okay. Microkernel architecture, you can see core. You can actually build different plugins, and you can add these plugins to the core systems, extensible plugins, right? You have a core system, and you are going to build different plugins for different features, and you will integrate those plugins to the microkernel architecture. So microservices architecture, as I told you, you're going to create a separate service for each functionality as per the domain-driven model. And you see here, each service will have a separate database, so the maintenance would be very easy, and you can handle the separate service as a separate database also. Getting it right, so that way you will do it. Okay, this is nothing but system design. So this is how the system design concepts, you can see microservice, where I'm going to explain microservice here. You can see we have a multiple clients. So client is interacting with different endpoints. You can see client may interact through the web browser, he can interact through the mobile, he can interact through PC. So the first request comes to the API gateway. So API gateway is the main thing where we actually aggregate all the responses. Also we will configure different cross-cutting scenarios like security, authentication, authorization, logging, routing mechanisms. We will configure all these things here. And service discovery, register and service discovery, as I told you, when we have multiple services, right, we need to register each and every service with a service registry. That way whenever request is coming, so the routing request will be identified and routed to the particular service using service discovery. Identity provider, as I told you, so you can need to configure the identity provider, identity management. You can actually configure the authentication and authorizations details here. Access management configurations you can actually configure using identity provider service. So for monitoring also, you see, you can have a separate visualization dashboards. You can use Prometheus, Kibana, or any other Datadog, any visualization software, third-party softwares, and you can push the information. You can use visualization data or monitoring. Other thing is you can monitor system health. You can use this. Spring Boot is providing actuators also. You can configure third-party monitoring system, as I told you. You can actually create a centralized dashboard for visualizing the health and request propagation of multiple services in a single dashboard. You can do that. As you can see here, the microservice, different microservice, shopping cart, billing, user profile, and different databases for each service. You will have a different database. So the benefit is here, you can have a separate team for handling different data sources. So when it is a bigger system, very complex system, you take Amazon, Flipkart, very biggest e-commerce platforms in the market. They need a separate teams for handling the separate service. They do the business of millions of dollars. They actually handle every day, right? So it is very important to have a separate team for separate service. Every service is a very crucial and critical for them. So they'll have a separate separate service. So that way you can actually design a system. I hope you understood that. I explained multiple designs, right? You see, in high level, the key components of the system, you see, in the high level, we will always have the three parts here majorly. First thing is web servers. Web servers for deploying any user interfaces. You take any application, if you look at any SDLC, software development lifecycle of any application development, and three stages we will deploy. First stage, we need to have a web servers. Apache Tomcat or any other web servers are there available in the market. You need to deploy a UI application. UI application generally consists of only HTML pages or JavaScript or Bootstrap, CSS. It consists of all these technologies. It does not consist of application layer like Java or any other technology. So the UI application will be deployed in the web servers as a separate service. So we need to have a separate servers for user interface application, because we always follow the MVC model, right? Model view control. So the model should be separate, the view should be separate, the model business logic should be, the controller also should be separate. So application servers for deploying the Java applications, actual business logic, actual Java layer will be deployed in application layer. can have IBM WebSphere, WebLogic. So servers are there for deploying the applications. Deploying a databases, you need a database server, separate servers required. So and we will configure the load balancing between the web servers and client, because that way, depending on the traffic load, and we can actually scale up the web server, web applications, or we can also scale up application servers. You can also have another load balancer between web servers and application servers. That way you can do it. Okay, I hope you understand this, right? It will be so useful for you. I explained a couple of system design architectures and couple of components, basic features, basic components, key features, key components I explained you. Thank you for listening.